with the second section and the third section, because if you don't know what these graphs look like or what the different variables do to the graph, then of course you're not going to be able to figure out which graph goes with which, or how to graph it, or what the domain is, or where the asymptotes are, or anything else, okay? So please make sure that you ask your questions when you have them, so that way we can address any issues that we have, okay? So you need to remember, just like with the word problems, same things with graphing. Period and phase shift affect your x's, amplitude and vertical shift affect your y's, okay? Think about it when we were trying to figure out, I don't know, like the height of a wave. Those heights were your y's, that was your amplitude and your vertical shift, and then, you know, I don't know how many hours it took to, or how many seconds it took for the wheel to go all the way around. That was your time. That relates to your period and your phase shift, okay? So those two components affect your x's and your y's. Don't forget about the rule. You take your x's and you multiply them by 1 over b. And then you either add or subtract your phase shift, which is the formula of what? What's the formula for phase shift? Negative c over the absolute value of b. If you don't remember that, if you didn't write it down yesterday, write it down today. Okay? So, it's not c that you're adding and subtracting, it's whatever number it is once you divide c by the absolute value of b, and of course, change the sign. Now your y's get multiplied by a. A represents the what?
Amplitude.
Amplitude, that number that was in the where? Front of your trig function, plus or minus your vertical shift. What variable represented your vertical shift?
D.
D. So in general, you have to figure out where A, B, C, and D are located in order to do this, right? Y equals what in general?
A cosine.
A cosine or any of the other three, all 6, okay? Whatever the trig function is, it's the same setup for every single one of them. A trig function, dx. Okay, now do realize that when it's a plus or minus, it's always going to be the opposite when you're doing the phase shift, okay? And also, does this always have to be x?
No.
What other thing could be here?
Any letter.
T,
Letter.
any letter right here, or any Greek letter, such as
Sigma.
theta. That was the one that was used the most. Theta was used the most, okay? And then G is again your vertical shift. So, if you forgot this, commit this to memory, okay? Commit it to memory. We're going to look at a couple. All right, let's start here. And on top of that, we're going to be doing some additional information like find the domain, find the range, like we are going to do for this problem. So, what is happening to my x's? I'm going to multiply them by what number?
1.
1 over b. What's b?
1.
1. So I'm going to multiply them by 1, and then I'm going to add or subtract. Subtract my phase shifts. And the reason why I subtract, because remember, phase shift is negative c over b. So negative c, what's c in this problem? Pi over 2. All over b, what's b? So that's why it's going to be a minus pi over 2. Does everybody see that? Make sure if you have any questions, you ask them, guys. Don't be shy. Don't think that your question is a stupid question. And don't think that you're slowing me down or anything like that. This is for you guys. Okay? I'm going to multiply my y's by what number? 4. And then add or subtract? 0. There is no plus on this side or in the front to say that it's moving up or down. So I only have to multiply by 4. So far, so good? What are the x's that I'm referring to? 0, pi over 2, pi, 3 pi over 2, and 2 pi. And specifically for sine, what are the y's that I'm talking about? 0, 1, 0, negative 1, 0. Now, the only one person who said that was maybe a little nervous. So where are those values coming from, guys?
From the original sign. The original sign.
The original sine graph. And where did the original sine graph derive from? Unit circle. Okay? Remember that sine was y, cosine was x. So So when you're looking at those angle values, that's where they're coming from. Hence why we did the unit circle first. Okay? So you're pulling these out of my butt. Come on now. So, I'm going to multiply all my x's by 1 and then subtract pi over 2. So when I do that, 0 times 1 minus pi over 2 is what? Pi over 2 times 1 minus pi over 2. 0. Pi times 1 minus pi over 2. And after the third one, you should notice there's a pattern, right? What's the next one going to be? And the one after that? Questions? Everybody knows that when you have a whole number and a fraction, in order to subtract or add these, you have to have a what? And what's the common denominator here in this for this particular one? It's going to be a 2. So you have to multiply not only the bottom, but the top by 2. And then you just subtract straight across the top. That's where pi over 2 came from for this one. What's happening to your y's? Multiply by 4. So the first one's going to be, keep going. And again. Last one. Awesome. True, because it repeats the pattern. Okay? So when I plot this, I'm at negative pi over 2. Negative pi over 2 is 0. That's the point I plot. 0, 4. Pi over 2, 0. Pi negative 4. 3 pi over 2, 0. And that is one complete cycle. What's happening after 3 pi over 2? It's going to go back up. What's happening before negative pi over 2? Goes down. Because these are continuous functions. They go on and on and on forever, meaning that their domain is what? Because it relates to your x's. They just keep going along this pattern. My range relates to what variable? Do my y's go on and on forever?
No.
Negative 4, 2, and are negative 4 and 4 included?
Yes.
That is your domain and range. Sine and cosine are bounded between whatever their amplitude is, or whatever their max and min are. Domain goes on forever. Tangent and cotangent are different. Secant and cosecant are different. Why are they different from? Because they have asymptotes. And so when you're doing domains for those, you have to be able to recognize where your asymptotes are in order to figure out what the domain and range is. Questions? So let's look at one like that. We'll come back to this tangent one. Let's look at number 3. We're going to graph its reciprocal function in a different color, as well as identify where the asymptotes are. Because remember, to graph your reciprocal functions, you need the original sine or cosine. Okay? What's the reciprocal of cosine?
Secant.
Just secant. I didn't say cosecant.
You said that's a good
I heard cosecant. No, you could just say cosecant, and I was like, so together. Here we go. And actually, before we do this, let's do a little bit extra. Let's do a little bit extra here. What's the amplitude?
3.
3. What's the period? 2. You have to do period equals 2 pi over b. That's how you find the period. What's the b in this problem? 1 over 2. So remember, theta is like your x, so you can easily say it's 1/2 theta. Can I leave it like this? Key, change, flip, and it turns into 4 pi. Is everybody okay with keep, change, flip? So it felt like that was an issue when it came down to doing your adding and your multiplying. What about my phase shift? Negative C over B. What's C in this problem? So I have negative 5 pi over 6, and I'm going to divide that by B, which is another 1/2. To simplify this, I have to keep, change, and when I flip the denominator, what does that turn into? 2. It will be negative 10 pi over 6 if I multiply straight across, but that reduces negative 5 pi over 3, and that's my phase shift. That's going to come in handy when I have to add or subtract it, correct? That's the process you go through. Vertical shift. 2. The equation of your midline. Some y'all. Equation of midline. It's not a trick question.
Y equals 2.
Y equals 2. It's whatever your vertical shift is, just with a y equals in front. It's that equilibrium line that's cutting our graph in half. It's always D. It's always y equals D every time. Every time. Hope by doing this, some of you guys are realizing that, oh yeah, on that one particular problem, I think that one wrong. Okay? So that's the hocus. What about frequency? What's frequency?
Frequency is
It's 1 over your period, so 1 over 4 pi. Now, sine and cosine have amplitudes. Yes, they do. But secant, cosecant, cotangent, and cotangent, tangent, cotangent do not have amplitudes at all. Just think about it. The amplitude is the horizontal distance between your max and your min. Okay? That's bounded in between your graph. But if you think about tangent and cotangent, do they have maxes and mins? No, they don't. And if you think about secants and cosecants, they have maxes and mins, but they don't connect to each other, do they? They go in opposite directions. So they'll never have an amplitude. Okay? They'll never have an amplitude. So, questions on extra information? Then let's do this. I multiply my x's by what number?
2.
2. It's always 1 over b. B is 1/2. So 1 over 1/2 is 2. Then I'm going to add or subtract my phase shift. And we just figured out what it was. I just erased it, but hopefully you wrote it down. What was it? What's happening to my y's? You multiply by A and add your D. My x's, do they change? I mean, like the original x's. Nope. They're the same all the way across the board, no matter whether you're doing sine, cosine, secant, cosecant, cotangent, or tangent. But my y's. 1, 0, -1, 0. Those do change depending on which trig ratio you're dealing with here, okay? So all I want you to do your y's first, a little bit easy. Do y's. 30 seconds to do your y's. Run them down. 5, 2, -1, 2, 5. Good stuff. Had to do your y's first because your x's are going to involve just a little bit more math, okay? But I want to do it with you guys just to make sure we're okay. I'm first going to start by multiplying every single x by 2. What's 0 times 2? Pi over 2 times 2. Pi. Okay? Pi times 2? 3 pi over 2 times 2? 2 pi times 2. Then I'm going to take everyone. Okay? Gonna take every single one and subtract 5 pi over 3 from it. Okay? The first one will be easy because, hey, it's just 0. But the next ones, we're gonna take maybe a little bit of math. Because the only way I can subtract a fraction from a whole number is if I have a what? A common denominator. What's 0 minus 5 pi over 3? Pi minus 5 pi over 3. What's my common denominator here? So I need to multiply not only the top, but the bottom. So it's going to be a negative 2 pi over 3. Common denominator? So what does 2 pi turn into to have a common denominator? So what's that going to be? Now hopefully you notice a pattern. 4 pi over 3 is going to be the next one. And you will get that still if you do the common denominator thing. But I'm telling you, because those 5 are divided up into quarters, they're going to have a pattern. All right? So with that being said, my graph does not allow me to graph the negative 5 pi over 3 and the negative 2 pi over 3. So help me out. If I follow the same pattern, what is the next x value after 7 pi over 3? It's going to be 10 pi over 3. Because again, the pattern, you're just increasing your numerator by 3 units. What would be the next y value that goes along with it? 2. Remember, it repeats. What's the next x value after 10 pi over 3? And the next y value? So now I can just graph my positive values. Pi, negative 1. Pi over 3, negative 1. 4 pi over 3, 2. 7 pi over 3, 5. 10 pi over 3. And if you're wondering, well, where is 7 pi over 3? Where's 7 pi? It's bigger than, it's basically 2 and 1/3. So it's bigger than 2, less than 3, but definitely also less than 2 and a half, right? What about 10 pi over 3? Where's that located? Right after 3 pi. And then 13 pi over 3? Right after. So I have one complete cycle here. Questions? Talk to me. Around time. Up real fast. It asks us to graph the reciprocal. If you remember anything about the reciprocal functions, there are asymptotes. They point up, they point down. They're parabolas. Where do the asymptotes occur?
At the x-axis. Where it crosses the x-axis.
Where it crossed the x-axis. The only difference with this problem is it got moved up 2 units.
So that'd be it.
So now you're looking at where the graph crosses 2 instead of the x-axis. So I have an asymptote here at this value. What was that x value? And where's my other asymptote? And remember, wherever there's a max, you have a parabola going up. Wherever there was a min, you had a parabola going down. So the blue represents the secant function of this. Remember, secant has no amplitude. Now the asymptotes. Once you graph it and you can figure out where the asymptotes are, it's not too bad. I'm asking you to identify all of the asymptotes here. So you always start out with one of your asymptotes. Give me one of your asymptotes. So you write that down. Then you try to figure out how far are these two asymptotes away from each other. How far apart are they? 6 pi over 3, which is the same thing as 2 pi. So that means that every other asymptote after it is going to be 2 pi radians away from the previous one. So how do I represent that?
Plus 2 pi.
And n is a what? And there are your asymptotes. And it works that way every time. If you can figure out where your asymptotes are, you write down the first one you see, figure out how far apart they are, and just add it into that distance. Okay? Those asymptotes also represent what information about secant as well. Where else could I use those asymptotes? What other information that I could possibly ask you to tell me? Or use that same information? To find domain. If I ask you to find the domain, it would be all x's such that x does not equal all of this, and then x is the element of what? All real numbers.